Okay, so when you had two equations, our answer looked like an XY, right? And on a graph, it was the intersection point of two lines, basically, correct? Okay, when you get three equations and you got three variables, it's more about 3D stuff. And so if you have one solution, it's like looking at three different planes and the one intersection point of those three planes. It's like looking at, think of the corner of a box where the bottom, like you don't have a top, but you have a bottom, and you get the one side and you get the other side, and that one vertex, that's like the intersection point of the three planes, and that would be your solution, okay? So that means that, and they're called consistent, if it has at least one solution, and your one solution is going to be an ordered pair, you just got three vertices or 3 points to it. Okay?
Oh, that's fine. See, go in order.
Correct. Oh, yes, and I'm glad you brought that up because as we're doing these, it doesn't matter what letter you use. So always do them in alphabetical order, okay? So if the system has exactly one solution, that is an independent, consistent system. It's called inconsistent. I just totally butchered inconsistent. How to spell that? System. Woo! If it's no solution, okay? And when there's no solution, you just literally write no solution. Okay? No solution is where there's no intersection point. Okay? So it's like looking at three planes that are just stacked on top of each other. Okay? That picture always reminds me of those hanging shells, you know, and so they don't touch each other. You can put all your crap on it, but they never touch. That's going to be your inconsistent no solution, okay? And then if there's an infinite number of systems, then the system is called coincident, okay? And that means they all intersect all of the same place. All right? And when you do the solution for that, it's set in terms of one variable, okay? And so your solution is going to look something like this. There's specific steps to get to that, and we'll go through that. But 3 different ways that you show your answers, depending on what they are. Okay? All right, so let's do some of these. Woo-hoo. All right, everybody can see that okay? All right, step 1. Use equation number 1 and equation number 2 to eliminate one variable. I'm going to label our 3 equations. So I got equation 1, equation 2, and equation 3. Okay? And so I'm going to use equation 1 and 2. And I'm going to use elimination to get rid of one of the variables. Okay? So pick a variable. What one do you want to get rid of?
X.
Why X? X, because you only have to multiply the top by a negative 2. I like that answer. What if I wanted to eliminate Y? I could multiply the bottom by a 3. What if I wanted to eliminate Z? Yeah. Does it matter which one you eliminate? No. It does not matter. It's up to you. Do the easiest one that works for your brain. But we'll go with what Nick said. And he wants to multiply the top by negative 2. And so I'm going to get negative 2x plus 6y minus 8z is equal to negative 26. And now, using elimination, 2x minus 2x goes away. Y plus 6y gives me 7y. Z minus 8z gives me negative 7z. And 5 minus 26 gives me negative 21. Did I do all that right? All right. Step 2. And actually, before I even move on, I'm going to label this equation because I just created an equation. I'm going to label that equation number 4 because I want to keep myself straight. Okay? All right. So, use equation 1 and 3 to eliminate the same variable. That's the key word, that you want to get rid of the same variable. And technically, you could use 2 and 3, not just 1 and 3. The big thing is that you obviously can't do the same 1 and 2 again. You just got to use a different combination. But let's stay with our notes here. So if I have x minus 3y plus 4z is equal to 13, and equation 3, negative 2x plus 3y minus 3z equals negative 15. What variable do I want to get rid of? The x. So I need to multiply the top equation by 2. You with me? So that's going to give me 2x minus 6y plus 8z is equal to 26. Question? Good? What, did I make a mistake? Yes, and thank you for bringing that up. Technically you could, except I canceled my x's over here. And the goal is to get rid of the same variables. If I canceled the y's, then I'd be left with x and z. And x and z aren't going to match up with the y and the z. Okay? So, yes, you could. And I'm really glad you asked that. Huh? No, you need to get rid of the x. We have to get rid of the x. That's fine. All right, so negative 3y plus 5z is equal to 11. And I'm going to make that equation 5. All right, step 3, I'm going to use these two variable equations. In other words, number 4 and number 5. Because now it's just like a regular 2 variable like we did last week. So I can say 7y minus 7z equals negative 21, and negative 3y plus 5z equals 11. And now I'm just going to solve it as a regular 2-step equation. So which do you want to get rid of, y or z? All right, let's get rid of y. So that means I'm going to multiply the top by 7, or I mean 3, and the bottom by 7. Good. All right, 21y minus 21z equals negative 63. And the bottom would be negative 21v plus 35z is equal to 77. Y's cancel, and I'm left with 14z is equal to 14. So z is equal to 1. Did I do that right? Okay. Last step, and I'm actually, anybody parked by the fire hydrant today?
Yeah.
Last step, I'm actually going to say we have a step A and a step B. There's kind of like 2 steps because you're going to back what you know into the equations to solve for the other ones. I know Z is 1, okay? So I'm going to substitute Z into 4 or 5. Which equation you want to use, 4 or 5? Doesn't matter. You want to do 4? All right. So 7y minus 7 equals negative 21. Because 1 times 7 is 7. So when I add 7, I get 7y equal negative 14. And so y is negative 2. So in the biggest scheme of things, I need an x, a y, and a z. So far I have my z, I have my y, and now all I need is the x. So this is where I get into my step 4b. Now I know 2 of them, so I'm going to substitute into what I know into 1, 2, or 3. Which one do you want to use? 1, 2, or 3?
3.
Doesn't matter.
3.
All right, let's do 3. So negative 2x, because I'm looking for x, plus 3 times negative 2 minus 3 times 1 equals negative 15. So negative 2x minus 6 minus 3 equals negative 15. So negative 2x is going to be negative 6. And so x is 3. Okay, so it's not super difficult, but there's very precise steps to it. That's why I say the more you practice, the easier it kind of gets at it, okay? Part of it also is being able to like look at it and say, which is the easiest 2 equations I can do this in, all right? Okay, so let's do another one. What are the 2 easiest, looking at what we have here, what variable do we want to get rid of first? Does it really matter? We can. Like in the first equation, we had these 2 x's automatically canceled each other out. Let's get rid of x. Or you could have taken 1 and 3 and said, hey, my y's cancel out. Let's use those 2. So if you have some that you can just automatically go, boom, it cancels, let's move on, great. If not, pick the easiest. Okay? All right, so which one did you say you wanted to do? You want to do x? Alrighty. So which equation you want to work with? 1 and 3? Okay, so I'm going to use 1 and 3. If I multiply the top one, it's going to become my equation 4. Or no. My top one's going to become, I'm going to multiply it by a negative 2. So negative 2x minus 2y plus 2z is equal to 2. I multiplied it by negative 2 because 3 is a 2x. Is that good? Because now that cancels my x, and I get negative 4y minus z is equal to 7. That's my equation number 4. Okay, step 2, I used 1 and 3 last time. So now I either have to use 1 and 2 or 2 and 3. What do you want to use? What? 1 and 2? Okay. So this time, since x is 4 and I got to get rid of my x, I'm going to multiply by negative 4. So that gives me negative 4x minus 4y plus 4z is equal to 4. And number 2, I don't have to change. And so when they cancel, I get negative 7y plus 6z is equal to 20. Good? All right, step 3. We're going to use 4 and 5 and get rid of. So negative 4y minus z equals 7. Negative 7y plus 6z equals 20. Which variable you want to get rid of? Y or z? Y. Because you only have to multiply the top one by a 6. Perfect. Now, 7th period, they just automatically went for the first variable. Every time. Let's just get rid of the one that's first. Okay, that's fine. It works. They had to multiply the top by a 7 and the bottom by the 4, and, but it works. So don't get caught up into, hey, I have to choose the best one. It's still going to work, okay? All right, so negative 24 minus 6z is equal to, what's 7 times 6? 42? And so I get negative 31y is equal to 62. And so y is equal to negative 2. Did I do this right? All right, so let's back into, I'm going to pick equation 4 because actually it doesn't really matter. You want to do 4 or 5? What'd you say, Nate? 5? All right. So negative 7 times negative 2 plus 6z equals 20. And so when I add 14, did I do that right? 6z is equal to 34. 6 doesn't go into that. What calculation error did I do wrong? Say that one more time.
Because -7 times -2.
Oh, it's positive. Duh. How many times do I holler at you guys about that? Hey, 2 negatives make a positive. Guess what? It does. Whoops. Long day. Sorry, brain fade. All right, I like that better. Z equals 1. That looks much better. Okay, now that I know 2 of them, let's put it into 1, 2, or 3. Which equation do you want to put it into? Equation 1, equation 2, or equation 3? All right, Patty's saying 1. So x minus 2 minus 1 is equal to -1. X minus 3 is -1. And so x is equal to 2. So my answer, as an ordered pair, is going to be 2. -2 and 1. Good? Alright. I got 2 more for you. How are you feeling about these so far? It really is, it's one of those that you just kind of have to take slow, but you just got to kind of do them a couple times and you'll be fine. Okay, so equation 1 and 2, 1 and 3, or 2 and 3? What variable do you want to get rid of? Why do you want to do 1 and 2? I like that. Besides, look at equation number 3. It's already missing a z. If we do equation 1 and 2, eliminate z, we can jump that second step. That's like saying our equation 5 is already done for us. All right? So, yeah, let's do our z's cancel, and I'm left with 4x plus 6y is equal to 6. And I already have equation 3 as 8x plus 12y equals 0. That's beautiful. I can just completely skip that next step. And go straight into what do you want to eliminate from these two? Let's just do x. Why not? So I'm going to multiply by -2. And they cancel. That's perfect. Oh, but look, my y's cancel too. So if I don't have anything left on the other side, what do I put there? 0. And 0 minus 12 is -12. Say that louder. 0 doesn't equal -12. That is a false statement. Okay, and so if you get a false statement, no solution. You have those parallel planes. Good? 0 doesn't. No, it doesn't. All right. Which equation do you want to use? 1, 2, 3. What do you want? What variable you want to get rid of? 1 and 2. All right. Which variable are we getting rid of? Okay. And that leaves me with a y minus 4z is equal to -4. Alrighty, then second step, you want to use 2 and 3 or 1 and 4? Doesn't matter. They're both going to be. How about 1 and 3? 1 and 2? We just did 1 and 2. We can't do that one again. And we're getting rid of. Let's just do. What did you say?
1 and 4.
You can't use 1 and 4 because I can't jump to 4 yet.
2 and 4. 3 and 4.
You got 1 and 2. We already used 1 and 3 or 2 and 3.
3, 2, 2, 2.
Oh my gosh, you guys are cracking me up. All right, x minus y minus z equals 2. And 4x minus y minus 16z equals -4. I'm just picking for you. Hey, could I just subtract and get rid of those y's? Does anyone have to multiply by anything? Or let me rephrase. Why don't I want to just subtract and get rid of those y's? What variable did I get rid of in the first one? I want to get rid of my x. Make sure you stay with the same one. So let's multiply this by -4. And x's cancel. And I'm left with 3y minus 12z equals -12. Alrighty. So I got 3y minus 12z equals -12. So which one do you want to get rid of, y or z? Okay, let's multiply by -3. And I get -3y plus 12z is equal to 12. And my y's cancel. Oh, wait a minute. My z's cancel again. Crap, that leaves me with 0. Oh, but look.
0
It
equals
can't-
0.
0 equals 0.
That's a true statement.
That's a true statement. And so what does that mean? You're all solutions, okay? Or infinite solutions. And remember how we talked about at the very beginning, if you have infinite, then you have to show your answer like this. I'm going to show you how to do that tomorrow, okay? I want this to wash over once before we do that next step, okay? All right, so the game plan this week. There are some practice problems for you. Please do some of them tonight. Then tomorrow, we're going to do some problems together. I'm going to show you how to do the solution set for all solutions, then give you some time to work on them in class, okay? Thursday, I have a scavenger hunt for you. So I'll have problems around the room, and you solve them to go to the next one kind of thing, to practice a little bit more, because Friday is your first skills quiz over this. Now, your skills quiz for this section of it is a 5-part continuing thing. And so you're going to work with a group of probably 3 for each of the parts, okay? So you'll need to think about who in this room you want to work with, or if you want me to assign partners kind of thing. I don't care, but I want you to think about how that, because everybody has to work together. Because what I'm going to do is I'm going to give you a code, and you have to solve problems like these for X, Y, and Z to then break the code. And that'll be what we do on Friday. Okay? Good. Questions?